In problem number 6, we want to find the volume of the solid generated by revolving the region bounded by y equals x squared, which I've graphed in red, y equals 0, which is the x-axis, and x equals 3, which is the blue line. So then the shaded area in green is our region. And we want to revolve that around the line y equals -1, which I've graphed in light blue. So then in the next picture here, I'm going to show what this looks like when I revolve this around the line y equals -1. So basically I'm going to get like a mirror image of this around, or across, I should say, maybe that line y equals -1. And so I end up with a shape that looks something like this. And again, when it gets revolved around, we get this, solid shape that's got this hole in the center here. When we slice off like a washer, we're going to get something that looks kind of like that. All right, so now drawing our washer, talking about what is our inner radius and what is our outer radius of our washer. Well, again, the center of this solid is y equals -1. Now, if we just look at the shape that we are rotating it around to make this right here is the line x equals, or y equals 0, which is our x-axis, right? And so, again, when we're rotating around an axis that is not the x-axis or the y-axis, in this case it's -1, then our inner radius is going to be -1 minus 0. Because y equals 0 is the equation of the line that creates that inner radius. And then y equals x squared is this line right here, right? So that's creating our outer radius. Our inner radius was y equals 0. Our outer radius is y equals x squared. So then our washer is going to have an outer radius of -1 minus x squared. Because again, it's always axis of rotation minus the function. Okay, so setting up our volume integral to figure out our volume. We need our limits of integration, so we have to figure out what those are going to be. Now we are integrating along our x-axis again. So where does this live along the x-axis? Well, it lives from here, 0, 0, to here, which is 3, 0. So our limits of integration are with respect to x, so from 0 to 3. And then again, it's going to be area of the outer circle minus area of the inner circle. And we are integrating about the line x equals 1, so with respect to x this time, so dx. All right, so plugging in our pi r squared, area of the outer is going to be pi times, and then -1 minus x squared squared, minus the area of the inner, which is going to be pi times -1 minus 0 squared, dx. All right, so pull out the pi, and then we're going to need to FOIL that -1 minus x squared. So when we FOIL that, -1 times -1 is 1. -1 times -x squared is positive x squared times 2 of them would be 2x squared. And then -x squared times -x squared is going to be positive x to the 4th. -1 minus 0 is -1, and then -1 squared is going to be 1, but then times the negative will be -1. And then, of course, combining like terms, the 1 and the -1 cancel out. So we end up with pi times the integral from 0 to 3 of 2x squared plus x to the 4th dx. And now we are ready to anti-differentiate and then do the evaluation theorem. The antiderivative of 2x squared is going to be 2/3 x cubed. The antiderivative of x to the 4th is going to be 1/5 x to the 5th. And my limits of integration are going to be from 0 to 3. All right, so plugging in 3 first. And then plugging in 0 second. Those terms are both going to go to 0. So doing the math here, 3 cubed is 27. 27 divided by 3 is 9, times 2 is 18. So I end up with 18 here. And then 3 to the 5th is 243 fifths. So if I make a common denominator, 18 times 5 is 90. So I have pi times 90 plus 243 over 5. So 243 plus 90 is going to be 333. So 333 pi over 5 is my final answer.